In this section, we look at summarizing and grouping data. First, we want to create a frequency distribution to organize the data in a nice way. To do this, we separate the data into different classes, A through W. Then we can label the frequency of each. Now we label the frequencies of each class. 5 A's, 6 B's, 6 C's, 3 D's, 1 F, 1 I, and 3 W's. Summing up all the frequencies, we see we have 25 pieces of data. Another example, creating a frequency distribution for a number of TVs in a household. First, we split up the data into classes from 0 to 6 TVs in a household. Then we list the frequencies for each class. One for 0 TVs, 4 for 1 TV, 7 for 2 TVs in a household, 1 for 3 TVs, 2 for 4 and 5 TVs, and 1 for 6 TVs in a household. And in this example, there are 18 pieces of data. Next example involves continuous data. When figuring out how to set up classes, it isn't so clear in this case. To create a frequency distribution for continuous data, we need to determine a class width for each category. Here is how we will determine our class widths. When collecting data, the number of classes is up to you. Usually, in homework and class problems, the number of classes will be given. If you are wondering why we round up to the next odd number, here is a brief explanation. Probably will make more sense by doing examples though. And here we have more terminology. Again, these terms will probably make more sense when doing examples. Here are the general guidelines for grouping data into a frequency distribution. Now back to example 3. We want 5 classes, so we find our class width, Since we have a decimal number, we round up to the next odd number, which is 5. The first lower limit should be 3, since that is our lowest data value in our set. Now we can construct the frequency distribution. A common mistake here is going from 3 to 8, and so on. But remember, our class width is 5, so we only want 5 numbers in each class. If you use your fingers to count from 3 to 8, you get 6, not 5. So we have to go from 3 to 7. Now we label the frequencies for each class. We get this from the data on the previous page of the packet. Now we calculate the class mark for each class. This is where it should make more sense why we rounded up to the next odd number. If we have an even number as our class width, we will get decimal numbers for the class marks, which we don't want. Now we look at class boundaries, which is just filling in the gaps for each of our classes. So revisiting example 3, we use class boundaries to fill in the gaps as we see here. The pattern is subtracting 0.5 from the lower class limit and adding 0.5 to the upper class limit. The frequencies are still the same, as well as the class marks. Sometimes we want to look at distributions and frequencies in terms of percentages. This is called a relative frequency distribution. To find relative frequency, we divide class frequency by total of all frequencies. Now let's use example 3 to construct a relative frequency distribution. First, we rewrite using our class limits. Our frequencies, class marks or midpoints for each class, and now we use our frequencies to calculate the relative frequency for each class. Note that all relative frequencies should add up to 100%. Next, we will use example 3 to construct a cumulative frequency distribution. We start with labeling our class limits. With cumulative frequency distributions, it makes sense to label each class accordingly. Less than 8 units taken, less than 13 units taken, less than 18 units taken, less than 23 units taken, and less than 28 units taken. Now we calculate the cumulative frequency for each. Note that the cumulative frequency in the last class should equal the total of frequencies. When we interpret frequency distributions, we're interested in a normal distribution. This type of distribution is symmetric, bell-shaped. Let's do another example constructing a frequency distribution. We want 8 classes starting at 110 and class width of 10. Now that we have our class limits, we can label the frequencies for each class.